Today we're going to be talking about sketches and parts. So that's the, wow, I feel like I'm talking to nobody, but there's, at least you're here, Angelo.
Hey, we got a handful.
Oh, okay. Oh, do you actually have a reading on people that are joining like on YouTube or something?
Yeah, exactly. Got about 8.
Am I also supposed to be streaming this to Discord?
No. That's just for feedback, which I'll link in the comments in a sec.
That would be awesome. So I will make sure to get that up. I would love to get some interaction with this, but we'll do that soon. So for the course overview, session 1 today, we are doing sketches and parts. Session 2, we do a lot of assemblies. In session 3, we talk about drawing and the more advanced topics. This is the same schedule of sessions that we've had for the past couple of years, except this year we now also have the virtual options, as you can see here. So the first thing we're going to talk about is that this course, or over this 3 days, this session and these other sessions are an introduction to CAD that are meant to help you get started and to show how the methodology works and how we design things as engineers. So it's not going to teach you everything. It's just going to teach you more of how to start thinking about things, both in the building blocks that you have to use and also just the tools available to you and some of the nomenclature that we use in using CAD. So to start, we have a couple different options for CAD packages. This is just a brief introduction. As you will see, we have on one end, we have CATIA and Creo, which are more powerful. These devices up in the most powerful section, like CATIA and Siemens, these can handle large assemblies. So like when we're talking about industry standards, a lot of companies use these higher end products to make their assemblies, like for aircraft and such, because there are hundreds of components for some of these things. In the middle, we have SOLIDWORKS, which is a mid-level CAD package. It trades off some of its power that it can use for usability. So if you've used CATIA before, or you hear anyone talk about it, you will hear complaints about how finicky it can be sometimes and how difficult it is to get everything right, because CATIA is a very powerful package that swaps some of that user friendliness for being a very powerful and very capable package. SOLIDWORKS is a nice middle ground. We have a lot of power with it. We have a lot of ability to use it. And then, of course, we also do have a nice interface to get you started and get you ready to do CAD. So in general, the design process that we're going to be going by is as follows right here. We start by designing something, and when we design something, we typically get a lot of parameters from a client or from other parts of people on our team. So this design is a process where you go through and you negotiate every one of these hole placements and sizes with whoever else is a stakeholder on your project. Once you have a general idea of what you can make this product to be and what it needs to do, you can simulate it using SOLIDWORKS as well, using FEA analysis. So what that means is that we have this iterative process back and forth where we design a part to some certain specifications that we need based on the client and the stakeholders. We can test it to see how it will perform in various environments and under various conditions, and then we can modify the part as necessary until we get it to a state where it works enough, or it is has a high enough factor of safety, we call it, to where we can develop a tool path for the CNC called CAM. On our team, we use Fusion 360 for the CAM files, and they use that in the Bechtel Center. Or if you want to do manual machining, you can create a documentation file or a drawing, as we call it. This will be covered in the third session, but essentially, as you can see here, we've got the initial design, the validation, and then we have the files needed to create a physical model of this thing, either by automatic machines or by hand. Your basic workflow that you're going to be working through when you design a part is, at first, you need to determine 2D sketch geometry. Now, this entire session today is focused mostly on sketches because without good sketches, you cannot have good parts. We need to make sure we're defining all of our constraints, all of our dimensions, and so we'll be covering that a lot in the different types of things we have today. After you get the sketches, though, we can create a feature. This is an example of an extrusion. So we have just, you take a sketch and you make it 3-dimensional, or the Bechtel Center would actually consider this 2.5-dimensional, since the profile does not have any overhang or caverns in it like this. Those aren't exact terms, but essentially this would be called a 2.5 dimensional object, funny as it is. So now once you do that, you do have a solid 3D body, three-dimensional space, and then additional features on top of that to make it either more machinable or more usable in your part or your assembly. You can add features to the edge, such as chamfers or fillets or other post-processing specifications. To give you an idea of some of the more different extrudes that we have, an extrusion is generally what we call creating a 3D object from a 2D object, or a 2D sketch. So for a regular prismatic extrusion, you just take a sketch and you can translate it or project it up to a certain height, and that'll create your 3D solid. For a revolved extrude, you take a sketch and you can revolve it around an axis for up to 360 degrees of rotation to create a 3D object. And then we also have swept extrusions, which you can see you can make more funky shapes with that. And then, of course, the funkiest so far we have is the loft, which this is actually how we make complex geometry between two different shapes of faces. So you see with a loft, you can go from a circle up to a square, and it will slowly take, basically, it's like an integral. The difference between them, it slowly morphs this circle into this square shape. So that's pretty neat. These are just some examples of the kind of stuff you can do. So to get started, what we're going to do is we're going to open a new part, and I will show you some slides as well as some SOLIDWORKS. So let me exit this for a second just to make sure that I do not want to change that. So SOLIDWORKS is still opening, so I'll show some slides real quick just for a minute. So present from the current slide. So the first thing we do when we want to make a new part is we open SOLIDWORKS and start a new part file. And then what you see here is the only thing when you begin that is defined by your CAD file. So when you start a CAD file, the only thing you have is an origin and 3 planes. And through these planes, we can define all 3 dimensions of our sketches and eventually our objects. SOLIDWORKS has let me know that it's ready to go. So I'll just start a new part. Now let me switch back to that tab. Sorry, 1 second. SOLIDWORKS is a little slow. So going back to the slides.
Sorry.
Speaking of which, if I didn't mention it, these, Angela, are you saying something?
Never mind. Go ahead.
Okay, sorry. So to give you a brief introduction into some of the different parts of your part file right here, the first thing over here is we have the work area. This is where your actual sketches and parts will be when you're doing this. Over here we have the feature manager, which has your different controls things. So essentially you have, like it says here, the history of your entire part. So every time you make a sketch or you make a part, they will chronologically appear beneath this point. And you also have your controls over here, like your material specification, your equations, and we'll get more into that a little later as well. Up here you have the ribbon, which this is where all your tools are. So you can insert more with the View-Toolbars button, but essentially what you start with is your features, your sketch tools, your evaluation tools, and then there's more and more that we'll get to in the following sessions. This up here, we do not know if this has a name as of now, but it has a couple of different quick access tools, like your visibility of objects, your perspective. This is where you choose your view, and then you can make a section view as well, just to give you some of the tools. So the first thing we're going to do, we do not have this part today, so I'm going to simply open up SOLIDWORKS. I don't know how to close this. Get out of there. All right, so like we said, now I've got SOLIDWORKS open, and in a little bit we will have a more interactive session. But for now, I'm just going to show you kind of like we just saw. In the very beginning of your part file, all you have is this point, the origin, and your 3 planes. So to create a sketch, the first thing you need to do is to select a plane to work on. So I'm going to select the top plane. I'm going to hit the sketch button, and then that brings me to viewing the plane normal to the surface. So to bring you through this really quickly, I can just show you kind of how we go through and make a part. And this isn't, I'm not gonna, this isn't the detailed explanation. When we get to example 1, we will actually go through example 1 together. But for now, I'm just gonna show you this demo part. We have a rectangular prism, you see, with a little pocket in here and 2 holes. So to do that, I'm just gonna very quickly show you, you can start with a rectangle, and then once you have this rectangle, you just need to define the dimensions. So I'm going to call this, it looks like maybe it's 4 inches, and then I'll call this one maybe 2 inches. Like we said, like I said, I guess I'm the only one here really, but like I said earlier, we define these dimensions based on the constraints of our parts and what other engineers need. So normally you would ask people or figure out calculating what these parts need to be. Let's call this 1.5. But for now, I am just going to assume I know all these dimensions. So we have a part that is 4 inches long, 2 inches wide, and 1.5 inches tall. So that was just a very quick rectangular extrusion. The next step I'm going to show is I'm going to start a new sketch on this plane. Hit the sketch button. I'm going to make a new rectangle in here. And then as I've got this, I'm not going to go into too much detail about constraining everything right now, but in a minute when we do our altogether example, I will show actually constraining these parts. But for now, I'm just going to leave it so that I can show you that once we have our sketch, we can then do an extruded cut, which is another feature. And I'll just drag this to about 0.21 or so. Let's call it 0.25. And now you can see with just 2 sketches, I made a part with the rectangular hole in it. So now it's got some fillets on it, and it's got some holes. So another feature that we can talk about is fillets. So I'm going to select all 4 of these corners. And in our feature tree, in our feature tab up here, we have the fillet tool, which can round off those corners. And now this part is not only more machinable, but it is a little probably easier to work with as well because it does not have those sharp corners in the edges. We'll also talk about the hole wizard in a sec. Like I said, I didn't constrain this sketch, but we'll talk about that later. I just wanted to show you very quickly. We have this picture of a part. Look at that. And we've mostly made it very quickly. And that's kind of what we're going to be doing today so that you can just get an idea of how this shape comes about when we're talking about this. So to go back to the slides, when we're talking about sketches, we're talking about defining all of our degrees of freedom and making sure we have really good sketches. So when we're making a sketch, like it says here, you need to define the plane and the 2D coordinate system that you're going to be referencing. The 2D coordinate system is usually in reference to the origin. So whatever plane you choose, it will be defined automatically based on the origin. And then the plane, you can either choose, like we said, the front plane, the top plane, or the right plane, or you can create reference planes from a combination of stuff if you need more complex planes. But the point of the matter is that you need to have quality sketches if you're going to have quality parts. So that's why we're going to focus a lot on that today. I'm going to kind of peruse through a bunch of this for a little bit. The example that we really want to talk about here is this example right here. So this is an analogy for linear algebra. If you haven't taken linear algebra yet, then this is a good analogy that will help you later. If you have taken linear algebra, then this will make sense to you. But essentially, this is the process of when we're making a line and we're constraining it. So when we're thinking about our sketches, every element in our sketch has to be defined mathematically in relation to the origin, right? So what we have in this picture right here is we have a line, and each point on this line has a y-coordinate and an x-coordinate, and they need to be related to the origin. So this picture right here has 4 degrees of freedom, as we call them, 1, 2, 3, 4. So the equations actually are not on this version, so I'll have to go through it and just tell you. But essentially, in this picture, y1, y2, x1, and x2 are all not defined. So we need to define them in relation to the origin. In this first picture, we have a vertical constraint noted by this green box right here with a line in it. Or this is actually a horizontal constraint, sorry. So what this means is that for this constraint, this is defining one equation. We're saying y1 is equal to y2. And now that we have that one equation, we have only 3 degrees of freedom left. Angelo, since they can't respond right now, do you want to give me feedback and if this is making sense?
No, it sounds pretty good to me.
All right.
It's hard to put myself in a state of mind where I don't, I guess, understand that.
What did I do? Oh, there we go.
But no, it sounds pretty good to me.
Okay.
And I don't see anything on
we'll hop
YouTube.
on the Discord in a little bit to get some feedback from everyone else.
Yeah, and actually.
But what we have.
Oh, I was just gonna say, I threw the link to the Discord in the YouTube comments for anyone who's listening.
Maybe I can just go ahead and open it right now then. All right. So where would they be going? Is it the IEEE Discord?
No, it is the. Here, I'll send it to you on Slack. Set up a separate one.
Oh, is this a whole new workspace?
Yeah. Wait, that's the wrong one.
Oh, okay.
Oh no.
Yeah, that's the Git
Did I
workshop.
link the Git one? Oh no. Oh, cool.
What's really funny is that I'm pretty sure one of the people on the stream right now is listening from the basement of my house.
Hey.
All right, I'm clicking on it. All right, you guys can take a look at that nice part we just made. All right, I see one person in the voice channel, Logan. So I will join the general channel, and you should be able to hear me. I'll actually probably mute the Discord channel for myself so that you only hear me through the stream in case there's a delay. But going back to the slides. Oops, not that one. Don't look at that. Don't want to give out that stream key by accident. All right, so for those of you listening to the stream right now, if you want to hop in the Discord, we'll be able to do an interactive session in a minute. And once we get to that, we'll have breakout and we'll have a back and forth, be able to interact. But for now, we'll talk about this. So getting back to this, in this first picture, we have 4 degrees of freedom, y1, y2, x1, x2. In this one, we have one equation that defines this coordinate right here. So we're saying y1 is equal to y2. So now this line is vertical. As we move to this picture, we are defining the length of this line as 18 units. So what that means is that x2 is equal to x1 plus 18. So now if we move, basically as you see this, if we move this point right here, this will move along it. I can actually show this. Tyler showed this yesterday. I can do this too. Let me delete these. I don't. All right, never mind. I'm starting a new part. Forget that old part. We got a new part. So going on the top plane, I think it'd be easier to just walk through like this. So essentially, we have 4 degrees of freedom, like we talked about. 1, 2, 3, 4. If I move this dot over here, there's nothing holding it down. And if I move this dot, there's nothing holding it down. The first thing we can do, like I said, define this as horizontal. Now we have a horizontal line so that if I move this dot up, the other dot moves with it because y1 is equal to y2. And you can see that that is defined by the green constraint box right here that shows the horizontal. To define another equation for another degree of freedom, we can define this as, like we said, 18 millimeters, which this is actually, I'm in inches right now, so it's going to default to inches. But now, if I move this dot side to side, the other dot follows it because we've defined their relationship to each other in the x direction. But now we still have 2 degrees of freedom. We can move in the x and we can move in the y. So we need to relate this back to the origin. So the way we can do that is we can link this point to the origin right here, make it coincident. And then once we do that, we have defined y1 as equal to y2 being 0, and we've also set x1 as equal to 0. So now our four equations, as you can note, are y1 equals y2. We have x2 equals x1 plus 18 millimeters. Our third equation is y1 equals y2 equals 0. And then our fourth equation is x1 equals 0. And now, as you see, this line has turned black, which means that it is fully constrained. So if we went to make this part or machine this part, this is a physical dimension that is fully defined and that could be created in the real world now. Going forward here to the next thing, you just see some of the more constraints. There's something called a fixed constraint, which can automatically lock something into place, but we don't use those because that is a bad practice to define something as fixed. However, there are cases that it can be used, such as if any of you are ever going to take CGT 163, you will find that Craig Miller, or he doesn't teach it anymore, but he did as recently as last year, he will normally say that using fixed geometry for splines can sometimes be acceptable because spline curves in CATIA can be very hard to define mathematically at times. So the first example we're going to do is this guy right here. Now, if everyone could hop in the Discord, I would love to be able to have this be interactive feedback as far as if people are able to get in the Discord, because it's just me and Logan right now.
I don't see anybody in the comments or anything. I linked it. We'll see if...
What if they're just watching with the sound off? Oh no.
I hope not.
Okay. Well,
if not,
for the next example, I'll make sure that we'll make this one an interactive activity where we do it together. But this one, I'll just go through it at first to show what we do for something like this. So for this, I'm going to start a sketch on the top plane. So now we're in our sketch editor, and the things that I'm going to do first is generally when you're making something like this, you want to just draw the general shape of the part that you're creating. And then from there, we can start defining the dimensions and constraints. So what I'm going to do first is I'm going to come up here and click the line tool, which you'll see is also denoted by an L. So for this, I can go up and click this, or I can just hit the L key and it'll get me the line tool. So the first thing I'm going to do, it says there's a point at the origin, and then there is a line that goes like this. Then there's another line that goes kind of like this. Now the next part is the arc tool. So I am going to first do a 3-point arc by hitting the drop-down menu and hitting 3-point arc. And it looks like there's an arc from here to about here with something like that. Following this is another line segment, as shown. After that, this time I'm going to try a center point arc just to be fun, to show you another tool. So I'm going to click the center, click the radius right here, and then make an angle like that. So now we have that. The penultimate task is to loop this back to the origin with that line. And then the final thing, I'm going to make a circle right about here for the hole. So as you can see here, we have the general shape, but now we have to go through and make some dimensions on it. I was just informed that I can't see the chat. Angelo, do you know anything about that?
The chat's on Discord or YouTube?
I think on YouTube. Thank you, Ashley.
Yeah, I'm looking at it right now, but I don't see anybody.
What does the chat say?
I don't see anybody commenting on it. It's mostly been me. Oh wait, never mind. Somebody asked if it'll be recorded for playback. Oh, somebody asked for the Discord link. Oop, let me put those. Yeah, you're good. I got it.
Okay, cool. Is that in the IEEE workspace?
Sorry, the IEEE. What do you mean?
Oh, I see that someone said that the Discord link does not show up on YouTube. So that's why no one's joining. It's not because they didn't want to join. All right, so here is someone. Perfect. Someone now has been able to join us. All right, so Angelo, I don't know how you want to go about that. It looks like 2 people were able to get in now.
Sweet.
But yes, so we're so maybe now maybe Karina, I see, has entered. Karina, did you get the chat from the ROV Discord? Did you get the link from the ROV Discord, or it wasn't available on YouTube or something? All right, she's still working on it, maybe. All right, well, Angela, hopefully you can work out with other people if they cannot see the Discord link. But the first thing, I'm going to start getting done with this. So the first thing I'm going to do is I'm looking at all of these green box dimensions. Oh, I see Karina has her mic on now. Were you not able to see the link in the YouTube, Karina? I cannot hear you if you're talking. Or her mic's muted again. All right, never mind. Okay, so first thing I'm going to do, I'm going to add some constraints to these things. So like we said, the green boxes are the constraints, and the dimensions are the actual numbers here. So what we're doing here is that step 1, I'm going to make this horizontal right here. And that didn't add the green box, but if you click on it, you'll be able to see it. Sometimes it hides certain constraints. So now what we have here is we have the horizontal constraint and the coincident constraint with the origin. So we're on our way. The second thing I'm going to add is if we, let me see if I can zoom in on this at all. I'm going to try to make this bigger for you guys so everyone can see it. All right, that's a little better. So now that we can see it a little better, you can see right here, we have a tangent constraint. So that means that the way that we're going to do this is I'm going to hold down the control button, select this arc length, select this line, and then we have related relations between these 2 lines. So to create a tangent, it's going to make this line in tangent with the arc, and that's one constraint we can add. So that's going to define that. You can see we've got that constraint on there now. And I'm also going to do the same thing up on this part. So I'm going to click on this line, hold down control, and then hit this arc length. And I'm going to hit the tangent relation. And now the tangent looks like that. Based on these pictures up here, it looks like the same thing is happening up here. So what I'm going to do over here is I'm going to select the arc, hold down control, select the line, and then I'm going to again do the tangent feature. And while we're over here, I'll do the same thing over here, select, control, select, tangent, and now we're starting to take shape a little bit like our part is supposed to be. To go through and add a couple more relations that we have, I'm going to see right here we have a perpendicular relationship. So I'm going to select, while holding control, both of these lines and add a perpendicular relationship. Ooh, there we go. Another relationship we have is a parallel constraint between these 2 lines right here. So I will select both of those, and as you see, when I mouse over this, it actually brought up the relations in a little toolbar, which is a thing you can do as well. But for now, I'm going to keep using this section right here to make parallel. So currently, all of our stuff is still blue, except for this line down here. Now, it's interesting that this line is black, but you will notice that this point is still blue. So there is still a degree of freedom on this line, However, this entire line up to the end point is currently defined in our sketch, but you can still change the length of this line so it is not fully defined, which we will fully define it in a second here. Actually, let's do that right now. So the next thing we're going to do is we're going to start adding our dimensions. So I'm going to go up here and click Smart Dimension, and then click this line segment right here, at which point I can define the length of this. So now by clicking, it will give me the option to change the length. I'm going to change this to the 3 inches that it says. And now that length is defined, and that endpoint is black again, as you see. The next step that I'm going to do is I'm going to go up here and define this length while we're doing lengths. So I'm going to say 4 inches. And now to make an angle definition, we have to select both of these lines with the tool, and then we can select which angle between these we want to do. As you can see, we can do between this end and here, we can do this obtuse angle, this acute angle, or this very large angle based on what you want. So there's a lot of functionality, a lot of different things you can do. For now, we're going to take this angle as it's defined and add it to 30 degrees. So now that we've defined that, we've got a couple more definitions that have popped up. You can see this line is fully defined, this line is now fully defined, and this line is defined except for the length of this point. So how do we start defining some of these other things? As we see in this picture up here, there are 2 crosses, as you can see. Every arc and circle has a cross to denote its center so that you can put constraints between the center of a hole and the edge. So you can't really very easily define the distance between an edge of a hole and the edge, but the center is always constant. So we can, if we need to, we can do math to make sure that this distance is enough. But we always define holes and arcs by their center point, not their distance from the edge, like that. So the first thing I'm going to do, you can see on this picture, is that the distance vertically, or horizontally I should say, between the origin and the center point of this arc right here is 1.5 inches. So I'm going to click this point, click that point, make sure that I get to the right dimension. You can see that based on where I move my mouse, the smart dimension will try a couple different things. It has vertical, it has beeline or direct line between the 2 points, or horizontal. If you are having trouble selecting which one, you can actually use the drop-down menu on the smart dimension and choose the specific dimension you want. So for this one, I'll want a horizontal direction. So now I select these 2 points, and no matter where I move my mouse, it says the horizontal direction. So that can be useful sometimes if you have a very complicated sketch. So once I hit OK right there, once I click, I'll get the option to change that dimension. And now we're getting a little closer to being done. A lot of the stuff that is left for us to do, however, you can see are these dotted lines and these dimensions, this dimension on this dotted line. So what are those dotted lines? This is a construction line. Every solid line that you see right here is an actual defined, well, they're all defined lines, but these lines actually define the outlines and features of parts. A construction line, however, is a reference line that we use to place these features in their specific locations. So the first thing I'm going to do is I'm going to go to the line tool, hit the drop-down bar, and then I have the center line tool. This is also known as our construction line. And then if I just make construction lines like this, then I can make these construction lines up to these surfaces. Now I specifically didn't make them perpendicular to show you if you need to make them perpendicular, we can hold down Control, press both of these, and then make another constraint like that. But when you're making these, you will also notice that if I go back to this construction tool, I can make this perpendicular based on these yellow guidelines that you see here. So I will make this perpendicular to this right here, and now we have 2 construction lines to define the middle of this hole. So now the next thing I'm going to do is I'm going to put in this 1.5-inch dimension right here. And while we have the dimension dimension tool up, I will click on the circle and make this the 1 inch diameter that it is supposed to be. So we're almost done here, but we've got a couple things left. One thing you can do to see where your part still has trouble is you can try dragging points around. So I'm going to drag this around and I see the size of these arcs is not defined. So I can look on this picture and I see that there is an equal sign and it's labeled as constraint 11. And this one is equal sign constraint 11. So that's how I know that these two arc lengths are actually set to be equal to each other through a constraint. So I'm going to do that same thing. I'm going to hold down Control, select both of these arc lengths, and I have an equal constraint, which will make them of equal radius. And now our outline of our shape is actually fully defined, as you see by it all being black. The second step, however, is that now our middle point is not defined, and as I drag this around, I see, this length right here is not defined. But if you look closely on this sketch, we have another equal sign, equal 20, equal 20. So relation number 20 in this sketch is an equal sign. So these are both 1.5 inches, which I will simplify by selecting both while holding Control and using another equal constraint. So if I hit the checkbox, it looks like we're done. We got the whole thing. The only thing that I will say is that now you can move around some of your dimensions to make it more readable for anyone who needs to work on it later. It's nice to clean it up sometimes. I've had some complex parts in the past where you have so many mixed components, it can be difficult to find or difficult to navigate it when you need to come back to edit parts later. So that was a little quick intro on how to do a part. We're going to try to hop over to the Discord now, which I see 2 or 3 people. Yeah, I see 3 people in here that are not myself or Logan. And if I exit this sketch, now we have a fully defined sketch that we can make an extruded feature out of, which I just go up, I hit the extruded boss, and now I can define the size of it. I'll call it 1 inch. And now we have a part. Look at that. Worked out great. So I am now going to take a second to make sure that I can actually hear people on the Discord. So I am looking at the Discord. I do not have myself deafened. I am going to check my settings to make sure that I have my output correctly. My output device is my speaker. So can you guys hear me? Can you guys unmute and talk to us if you can hear? Perhaps Logan.
It looks like you're still muted. Oh. I see them unmuted, yeah.
That's exactly what I would like. Yes, thank you, Logan. Hello. Is there a huge delay? Is there a huge delay between me and you right now? If I unmute myself on Discord, I'm unmuting myself on Discord. Is there a huge delay between the Discord and the stream?
There should be, Joe. If you want to hop into the Discord, I can mute you on stream. Just gotta let me know.
But they, none of what the people in this stream, none of their comments are going to be on recorded, or are they? Are they going to be recorded for the stream?
No. I mean, the real point of the Discord is to give them one-on-one feedback. But I'm trying to think. Yeah, I don't think we can manage that. I could try to capture the audio. That's what I've been struggling with right now, actually capturing the...
Well, in interest of just continuing the stream, we'll just work, you can work on that, continue to work on that, see if it works. Otherwise, I'll just repeat every comment that I get as I go, and we'll just do it from that way. So I'm going to mute myself. Do you think it's better to mute myself on the Discord or on the stream? Or just have people turn my sound off?
Yeah, they can turn your sound off, I think.
Very true. Yes, that's what I meant. That sounds good. All right, so everyone on the stream watching this afterwards, sorry for the delay. We're still working out the bugs with this virtual stream, but as you just heard Logan say on the Discord, if you're here live, we're going to have people on the Discord mute the stream audio from YouTube, and then we will have an interactive session while we make these other parts together. And I will just make sure to repeat other people's comments so that we have an actual good thing or resource for people to watch later if they plan on watching this later. So, people on the Discord, welcome. Or, well, I guess one person left. Oh, and they're back. All right, so if you all have the stream muted, the first thing we're going to do here is we're going to open up this part. So I'd love to do this together to where I basically have a part open and I'm like, all right, guys, what should we do first? So if anyone wants to speak up, I'm going to select the top plane. I'm going to open my sketch, and we're going to go through this together. What do you guys think when we're looking at this drawing? What do you think the first thing we should do is for this? Anyone who wants to speak up can do so. All right, so we got a horizontal line. So I'll put this in. When you say horizontal, do you mean full horizontal like this, or kind of angled like it looks like in the picture maybe? Okay, cool. So we've got one horizontal line. I'll go ahead and add another one on the other side since it looks like we need that. So we've got two horizontal lines. If anyone else would like to speak up, we've got a couple different features we could add here. If anyone has any suggestions for what we could do. Yeah, thank you for responding, but if BGR told me anything, it is that you have to use the silence to make people uncomfortable enough to actually respond. So, but wait, no, I've told you my tricks. Don't be quiet now. Four circles, you say? Okay, we can try that. Since we already... So I've generally got four circles. So we do have all the parts here. So I think what it looks like here is that these two circles, that sounded like a good suggestion. So I'll put these two to be coincident with each other, which if I just put the points together, those should form the coincident constraints there. Yep, so those are now bounded together. So now what's interesting, what constraint do you guys think would be useful for connecting these lines together with these circles? Because I'm thinking of a constraint we talked about on the last one that would probably work. Wonder if you guys have any ideas for that. Yeah, that's good. So I'm going to select both of these while holding control, hit the tangent button. That didn't quite work. So what I'm going to do now is I'm just going to drag this line segment all the way over to this edge. And you can see when I have it here, there is that line with the point on it. That's the coincident constraint. So it's telling me if I do this, it'll make this line coincident with the edge of the circle. So now I have the coincident constraint. I also have the tangent constraint, which is good. But something happened here. When I did that, it accidentally put on another constraint. It added a vertical constraint, which between this point and this point, which we don't want. You guys know why we don't want that? So the reason that we don't want this vertical constraint between this point and this point is that it restricts this line right here. This line now can't be angled like the bottom one is. So if we want this line angled like in this picture, or if we want this line to be tangent to here, then we need this point to be able to move so that these can be different lengths. So we need to actually go through and delete these relations. So I'm just clicking on them and then hitting the delete key. And now these circles can actually be made different sizes, and we can have our angle like that, right? While we're doing that, the next thing I'll do is I'll take this point right here and do the same thing we did already, make it a little coincident, make it coincident with this, and then I'll make sure that we are selecting both of them, making them tangent. So now, as you can see, we have the main geometry of the part, looking pretty good. So what do you guys think the next thing we should do is? All right. So what we're going to do, that's exactly right. What we're going to do is we're going to set an angle between these two guys to do the first thing, just to start getting our size in. 5.7 feet. You don't have to do this part first. We can be working on a couple different things. But for now, I'm going to set that, and we can just start going through and making some of our other dimensions. So it says here the distance between these two circles is 100 units. I'm going to call that 100 millimeters, since I believe all of these were created in millimeters. I got to change to millimeters. There, 100 millimeters. Oh, sorry. This is the right unit. All right, so what I just did there is where you can change the units of your sketch depending on what units you're in. You can hit this bar and you can be either in inch pound second, which is imperial units, millimeter gram second, or standard SI units, meter kilogram second. For smaller parts, we'll probably use millimeter gram second, since this is a small linkage, as you can see. But step one is to define this distance as the 100. And now what I see right now is we might have a problem. Does anyone see what the problem here might be right now? All right, very good. So if I draw a construction line right here and I make this horizontal like we had before, it worked out. It did actually work out. That dimension didn't change. The thing that I was worried about was that when we had it up like it was defining a horizontal distance between 2 points that were not level. So I was a little worried that that could have caused a problem with the actual defining of this dimension. So we might have had to delete it and start that dimension over if that was a problem. But we made this horizontal line to make sure that this was straight, and it all worked out. So that's good. While we're here, the next thing I'm going to do is I'm going to drag this point over to the origin just to help us define it a little more. So now you can see this construction line is now fully defined, and we will slowly bring all the other points around to being defined as well. The next thing I'm going to do is I'm going to take this smart dimension, and since we are given the inner diameter of this big hole, I'm just going to define this real quick as the 25 millimeter diameter. Move that into a place where it's easy to read. Over here, this hole right here is defined as 15 millimeters. And now we've got these outer circles. These are defined by their radius. So because we made these circles, when it comes up, it's going to automatically define it by diameter. So that's just something to keep in mind. This currently is asking for a diameter given a radius. So you just have to remember this is 31 millimeters diameter. And that actually fully defined our sketch, interestingly enough. So we didn't even have to go through and make that last dimension. But as you will see on this, this is actually an over-defined sketch in that it has a lot of dimensions listed on it for our use and helpfulness. But actually, if you make all of these dimensions, if I added one more dimension like the radius of this, it would be over-defined. And so there's too many equations to solve properly, actually. Back to the linear algebra analysis, we want to make sure that we have enough equations to define the entire thing, but that we don't have too many to where the computer can't solve it. As a side note, what you just saw right there, when I click this, you do have the option to make a reference dimension, though. So adding this dimension will make the sketch over-defined. So it asks, do you want to make this driven, or do you want to make it driving? So if you leave it driving, it means that it's trying to define the assembly. So currently, this is over-defined. But if I change this, if I click this and I go down here, let me see where this is at. I believe it's in other. Oh, so in your dimension properties in other, if I select the driven box, then it is grayed out and it becomes a reference dimension. So now if I ever need to know the size of this outer arc, I can look right here, but this will change automatically based on anything else in here. So if I call this inner circle 16, that'll automatically, well, actually that didn't change anything because it's this one that matters. If I change this to 32 millimeters, it'll automatically update this guy. So I'll change that back to 31. Now there's one thing left on this part that we have. You'll notice we have these extra lines right here that are not on the linkage. So if we wanted, we could finish the part right now and say that's done. Because if we wanted to create the part, what we would do is we would select the sketch, go up to extruded boss, and now, because there are multiple closed loops, we can simply choose all of the loops we want to include. So when we do that and we make this 15 millimeters tall, that's our completed part. Another way to do this, however, is if you actually go through and edit the sketch, there's something called Power Trim Tool. So this is a completely acceptable way to make your part. It's perfectly fine. But to be a little more accurate, you could also use the Trim Tool. So using the Power Trim Tool, you just hold down on one side of a line, drag it through an object, and as you see, it deleted the line segment between the intersection of this and the intersection of that. That's what the Power Trim does. It deletes everything between wherever the next two vertices are. So if I were to delete this construction line, if I were to drag through this line, it would delete from this point to this point. But if I delete this guy first and then delete this, it would delete between here and here, if that makes sense to you guys. So now what I have is this right here, where I can power trim that, and now the sketch is actually completely accurate to the part. So now if I hit the extrude, if I select sketch and hit extrude, I can fully do that all in one. Otherwise, like I said earlier, you have to go to this drop-down bar and select contours. That's what we did earlier if I didn't spell it out very clearly. So are there any questions kind of on what we just did right here? Are you guys following pretty well? I know that this format probably isn't super great compared to in-person where you'd be able to do it yourself, but I'm hoping that this kind of more interactive segment is still getting you some of the knowledge on how to do these things. Oh, shoot. You know what? That's something I forgot about too. The, just because the audio is in sync doesn't mean the stream is. All right. Ah, shoot. That's a really good point. All right. Well, we live and we learn. So I think what I'm going to do then is I'm going to mute my Discord audio. Well, actually, Logan, are you still listening? Do you have any thoughts on what we should do for this? Yeah. And then if we do it something like that, so everyone currently in the Discord, if you can unmute your stream, it seems like that's going to be the best thing. But yeah, I guess I'll just deal with the delay if you guys have questions. So I'm going to mute myself on the Discord. I'm now back to the stream audio if you guys have unmuted the stream. So as you can see for this, we got a couple of things. We got some good dimensions on this. We got some good practice. Another thing to go over just real quick is that you'll notice there are a lot of weird dimensions on this. And like we said, you don't want to provide too many equations to define the different things that you need. Otherwise, your part will be over-defined and over-constrained and it won't solve properly. So this picture here is over-constrained. The key as engineers that we need to ask ourselves sometimes, though, is what dimensions are important to control. For a mechanical linkage such as this, some of the important dimensions are probably the size of this hole, the distance center to center between these holes, and then the thickness of the part surrounding the hole. So when we're thinking about this unit here, this length overall of the linkage probably isn't as important for us. So if we decide, let's go back to our sketch right here. So if I show our sketch right here, if I determine that I want a stronger part, if I determine that I want this thickness to be thicker so that this part is stronger, currently I don't have any way to control that because this dimension is driven. So the only way I can change that is by changing this angle, which is not exact. So if I change this to 6 degrees, this gets thicker, but that's a way harder thing to measure. That's not directly measurable. So if we wanted to actually worry about the features that we cared about, we probably don't actually care about this angle. This angle is not important. What really is important is like the thickness here, and that's 8 millimeters. So now I have a dimension that has the same amount of equations, but I just changed one of my equations to be easier to solve for the parts I actually need to control. So moving on to the second part here, we have a box thingy with some holes in it. So we're going to get some new tools in this one, including Hole Wizard and the pattern tool. Let's do this. All right, so I'm going to start a new part here. Oh, actually, I should exit sketch first. So for this part right here, we need a box, basically. So the first thing that I'm going to do is I'm going to select the top plane, hit sketch, go to my new sketch. And now I'm going to try something new with this method where instead of making a rectangular box like this, what I'm thinking about is how am I going to create these holes? The easiest way to create these holes is with mirrors. So essentially, if you have an axis through the middle of these 2 points, you can mirror these holes over to where you can define at once and then copy it. So thinking about that, I'm thinking, what's the easiest way to make it so that I can mirror things, and that is to have the origin in the middle. So looking ahead on that, one thing I can do is I can do this drop-down bar right here and choose the center rectangle. I click on the center, and now I have some automatic construction lines that make a centered box. So now all I have to do is dimension my sides, 4 inches and 3 inches, like we talked about. And now, with only 2 dimensions, with only 2 constraints, we have a fully defined box. Or I should say, with only 2 additional constraints. The next step that I'm going to do now is I'm going to, while we're in this sketch, I'm going to create another center rectangle to create this inner pocket. Now, what we've been talking about throughout this whole thing is that there are an infinite number of ways, essentially, to CAD every single thing. So there's no necessarily best way. Oftentimes, there's plenty of ways you can do it. But for now, what I'm going to do is, since we're in the sketch plane already, I'm just going to make another center rectangle for this guy right here. So it looks like the thickness on all sides of this is 0.5. So I'm going to make this 0.5 thick right here. And I'm going to make this 0.5 thick right here. Now, one thing we can do as well, which is an extra tidbit, is we can use something called equations. So in this case, we want the thickness to be uniform around all sides, right? So one thing we can do is we can hit the equal button, which will create an equation, and I can click on this dimension, and now those 2 dimensions are equal. And you see the red sigma denotes the equation. One step further, for anyone interested, is that when we get into the full model, there's something called global variables. So if we wanted, we could take this dimension right here and set that equal to a letter. Let's call it T, thickness. So I'm going to create a new global variable called T, set it to 0.5 inches. And now in my equation manager up here, if I click on manage equations, you'll see a couple of things. The first thing you're going to see, global variable T, 0.5. Cool. And now you also see D4 sketch 1, which is this sketch right here, is equal to D3 sketch 1, which means that this is equal to this. And then the D3 sketch 1 is equal to T. So what we have is we've just created a dependency that we can change from the equation manager. So once we get to the end of the part, I'll show you how we can change the thickness of the box with just the changing of one feature. And that's part of your iterative process, where if you find out, oh no, we need a thicker box or a thicker part for this, you can change that with just one command, which is very convenient for when you're iterating through parts. Does that make sense to everyone? See you kind of following that? So the next thing I'm going to do is I'm going to exit the sketch. This is fully defined. So now I'm going to select the sketch, go up to my feature bar up here, and click on extruded boss. And now because there are 2 closed loops, it wants to know, or you can define either of these loops to create the sketch. So the first thing I'm going to do is I'm going to select this outer bar. And as it says on here, it's 1.5 tall total. So the way I'm going to do this, I'm going to make this 1.5 inches tall. But now I need the base. One way you could do this is by selecting this, creating a new sketch, and then one tool that we have is called convert entities. So if I click this, it'll actually convert all of the sketch elements on that plane into this feature. So now I have a completed sketch that I can use to make a new extruded boss going up. But I'm not going to do that because we already have a sketch down there, so I don't need another one. I can hit the drop-down menu on this boss, select the original sketch and make another boss. And you'll see that adds, well, in a second, you'll see that adds a little handhold symbol to indicate that there are two bosses made off of one sketch. But for now, what we have is we go down to the selected contours. And now this time I'm selecting the inner contour and I'm a little confused on where we are. Inner contour and outer contour. So now if I set this, we go region 1, region 2. So now I've selected region 1 and region 2, and the thickness of this base is 0.25 inches. So as you can see, I now was just able to make a fully extruded base out of the same sketch. So now, like I said earlier, there's a handhold symbol on these sketches to indicate that they're connected. And actually, I guess I made a mistake when I was doing this. You don't actually need to extrude this second region, since we do already have the middle region defined. But it doesn't matter which one you do, because as long as you have this box here checked that says merge result, it will combine them to become one complete body with no gaps or other changes. And merging result also automatically accounts for any overlap you might have, which is pretty nice. So now we have this box. The next thing we need to look at is how we're going to add these holes, right? So this is a time when I mentioned mirroring. Since we put this around the origin to begin with, this will be much improved of our process. So I'm going to click on this plane right here and start a new sketch. And I'm going to add the hole wizard. Actually, okay, I made a mistake. We need to use the hole wizard, which means we don't start a new sketch. So I'm going to discard changes for the sketch. Tyler wants me to use the hole wizard, so I'll use the hole wizard. So what we do for this, we select this plane, click on this thing up in the features bar, which is the hole wizard. And now, as you see on this drawing, we have several different dimensions, things. What do all these mean? The first thing we have is that we have this. It's a number 8 clearance hole. So we go over here and we change the standard to ANSI inch. And if we just select a hole, standard hole, I can go down here now and select the type. So I'm going to create a screw clearance. And so the size is defined as a number 8, and it is defined as being through all. So right now it's set to blind, which means that it'll just go a certain thickness through, but I'm going to set it to through all so that it goes all the way through the hole, all the way through the part. The reason we don't need a sketch for this is because the sketch is defined by the hole wizard itself. So if I click on the positions tab, you have the option to place holes. So I'm going to place one hole, and then I'm going to hit the escape key one time so that I can get to the dimensions. So if I look at this from the normal plane, you will see we can very easily do a 0.25 dimension for this, and a 0.25 dimension for that. Whoops, I accidentally made the same thing twice. There we go. And now, as you see, we have our origin in the middle here. Very convenient. What I'm going to do is I'm going to add 2 construction lines, one that runs along the middle in the vertical direction, and one that runs along the middle in the horizontal direction. If you did not line your part up with the origin like this, another thing you can do is that if you hover over a line segment, you can see where the midpoint is. So if I hover over this line segment, you can see the midpoint right here. And what I can do with that is that I can make a construction line between the midpoint of this line, hover over this line, find the midpoint. And there, I have a horizontal line in the midpoint, all the same. Very easy. Like I said, there's a million different ways to make every part. But what we're going to do right now is, now that we have our hole defined, everything is black, I'm going to go up to the Mirror Entities tool. So if I click that, I can click this entity to mirror, and I can mirror it about this. And now the hole will be defined over there. So I can check. You can't do two directions at once with the Mirror Entities tool, however, so I'm going to do it a second time. and I'll select both of these entities this time, and I'll mirror about this axis. And now we have 4 holes defined by this distance from the side. So if I change that, you see they all shift together, which is very convenient for changing dimensions and tolerances or clearances on these types of things. Sorry, check mark, and we have our 4 holes. Is everyone following so far on this? Not hearing any no's, I'll continue. So now, what else do we have here? One thing we will notice is these curved edges. So like we talked about a little earlier, we've got something called a fillet tool. So what I'm going to do is I'm going to click on this fillet tool. And under items to fillet, I'm going to select all 4 corners. Now, why do we do this? For this particular part, you will notice that we have square corners. So part of the reason we add fillets is A, because square corners like this are not possible to machine with conventional machining. So if we wanted to machine this part, we would need some kind of fillet here to make sure that this part is actually machinable. So this radius here is actually typically defined by the tool diameter that you're using. So when you are making a part like this, you can add a fillet based on whatever your tool can actually accomplish, as long as it fits within the parameters of your design. So if you need a diameter that is very small on these edges to fit all the stuff that is inside, you can use a very small drill bit, or a very small end mill, I should say. But essentially, you don't want to be having a radius of your fillet that is so small. You need a 1/16 inch end mill bit to get it done. Otherwise, you will have to either change tools in between operations, or you'll have to carve those down, do this entire thing with a 1/16 end mill, which is inefficient, and we do not want to be doing that. Which, to be more clear, a 1/16 inch end mill, for those of you who do not know, is going to be very small for a part that is 4 inches by 3 inches. It would take a very long time to shell out all this material. The second reason, or I guess this is the third reason we use fillets, is because corners are stress concentrations. So when you create a part, if you need it to hold up to pressure or something, so let's say if this was a lid, this part looks remarkably similar to a lid that was just 3D printed for our ROV robot. So if we're looking at this and this has to undergo several bar worth of pressure to survive at the bottom of the ocean or something, then the places where stress concentrates on this are at these corners. Because they're sharp corners, they are high level, they are where the stress concentrates, and so that's where the part is most likely to fail first. So by creating these fillets, we actually make it so that the part is more resilient to failure and has a higher yield strength. So that's one of the other things in FEA. If we actually were to do that, if we were to do part analysis, you would see these corners are where failure occurs first. I actually might be able to have an example of that. During the third CAD session, I'll show something we've been doing in machine design recently, ME354, which is an FEA analysis, just to show you what it looks like and to show why we don't leave corners unfilleted. So now we have a little fillet on there. The last thing we're going to add is this hole right here in the front. This is also using the hole wizard. So I'll click on the front here and click the hole wizard. But this is a metric unit. So what we need to go over here is we need to change to ANSI metric. It says that it is an M16 by 1.5. This is standard CG&T, or GD&T, I should say, nomenclature. So you don't necessarily have to understand this right now, or depending on your career, maybe never. But when we're reading a drawing like this, this is standard GD&T, which means that this is an M16 screw, and the 1.5 is the threads, which means that this hole is a pre-tap hole. So we want to go down to this, we want to select a hole, and we want to select tap drill. So what tap drill is going to do is it's going to make a hole that is the size you need before you tap it. So does anyone want to talk about what tapping is, or does anyone not know what I mean if I say tap, like to tap a hole? Okay, so if you all know what tapping a hole is, then I'll just keep going. But, you know, essentially you need a hole size that is the size of the hole before you thread it, which is what we're going to do right now. So we need an M16 by 1.5, which, since we're in the metric tap drills, we will now be able to select that. And it is a through hole. The through hole is defined as 0.571. So what we can do is we can either do it as a blind hole, which will simply go as far as we say to. So this we could do 0.571. But what is more convenient and what is easier for when we make modifications is we can do up to next or up to surface. If we do up to surface, then we select this surface and the hole will penetrate this surface. If we say up to next, it will simply select the next surface the same, but up to surface allows us to select other surfaces. So we could say the hole goes all the way to here, the hole goes all the way to here, that kind of thing. For now, I'll just use up to next to indicate this surface. And now we go back to the position tool. So I'm going to click on this face right here, hit escape one time, and now I can start making constraints just like we did before. So for this, we have 2 inches from the side. And we have 0.75 inches from the top. And depending on the part, we could do that the same way, where this is actually coincident with this point in the vertical direction. And we could say this is horizontally coincident with this midpoint over here. But for now, we'll just go off the drawing, since the drawing is what was given. And the other constraints were not necessarily given. So if I hit the check mark here, now we have our hole, it goes through. And now, like we said, if we were to analyze this part and find that we needed the wall thickness to be thicker, I'm going to go up to my equation manager right here, hit manage equations, and let's see what happens when I change my global variable t to be thicker. So I'm going to change this now to 1 inch. And hit update. So, as you can see, the thickness changed. What else changed? Because these fillets were defined by the corners, the fillets scaled in. They didn't scale, they stayed the same size, but they changed their position accordingly, which is good. These screw holes were defined in reference to the outside edges, so they did not move, which means that this part will still be able to be fixtured to the device it was originally designed for, which is still good. And now, since we did up to next on this hole is now still all the way through, which is good. If we had used this dimension right here, the blind hole, the hole would cut off in the middle and the part would no longer be valid. So it would need another dimension change to work. What's more, like we said before, as I changed the thickness of T, it changed both this dimension and this dimension, since we set them equal to each other through equations earlier. So that's just a fun little doodad, a little extra. And there we have it, the finished part. The final thing we can do, we go over this more in detail on the 3rd CAD session day, but if you wanted to apply a material, you could go over to the material manager, and for FEA, you need to determine what material is best for you for your part. So usually on the ROV team, we use 6010 aluminum, I think it is. 661, I think it is. There it is. So we use 6061 aluminum, which sets it to particular properties that we could run FEA on, and it changes the color just a little bit to help be a little more representative of what we actually work with. Got about a half hour left, so I'm going to start the 3rd part. Is everyone following okay, or are there any questions about what's going on right now? If you want to give me a little shout that you are following, okay, that'd also be cool. Nope, okay.
It's a pretty decent delay. I think it's like about 30 seconds, but I'm not positive.
Oh, is it 30 seconds? Oh, man.
Yeah, well, yeah, I have the actual delay set to 0, but I think it still automatically adds 1 in there.
Well, because we're going through Zoom and then YouTube, which is interesting because I can talk to you with no delay because you're on the Zoom call that we're on.
Yeah.
We should have just had them on the Zoom call.
Yeah, that might actually work. We'll do some
and then we could hear them. Then we could hear them on the stream too.
Yeah, well, my hope was to have you just sort of step through every example, and me and Logan could help them as they step through them and like pause the video and stuff. But that fell apart as soon as you couldn't access OBS. But we'll definitely have it a little bit better organized next week. This one.
Or next week.
Yeah.
Yeah, I was trying to set up OBS tonight, and I'm like, oh man, I've used this before, and it hasn't worked for me.
Yeah.
But Karina, yes, we did hear you. Thank you for your feedback. I'm sure you'll hear this in about 30 seconds. All right, so to start our next part, this one is a little more complicated, as you can see. So I'm gonna make this a little, you know what, Tyler's probably gonna be pissed that I'm changing his slides like this because I'm trying to be able to see them better.
Nah, that's fine.
But he can work on them. Order, move to front. All right, so what we have here, as you can see, is a much more complicated part. So as we say a lot of times with CAD, sometimes you have to find the best place to start, but sometimes you just have to start. So the first thing that I'm gonna do is I'm gonna start with this profile right here. This is a standard 3 view that you see in CGT and such. So I'm gonna start with the front profile, or this would be the right profile, I guess. Yeah, I'm gonna call it the right profile. So we're gonna start with the right profile. I'm gonna start a new sketch in the right plane. And like we did before, I'm just gonna go through and draw some of my lines in just to start. There's another line right here. And then I'm gonna use a 3-point arc to go from here to here. Oops, forgot to click a third time. And then of course we have a hole right here. I will add a construction line from here to here, because you will notice that this line is not actually a line per se. This is simply the edge of this cut right here. So when I'm extruding this, I want to extrude this entire body, is the point. So going through this a little quicker this time, I've got these dimensions. I'm going to add this one right here is 0.8750 inches. This one down here is from this edge to this edge is 3.1875. The radius of this guy right here, we can see, is 2, just 2.00. The distance from this hole to this side is 1.3750. The diameter of this is 0.6250. These are at an angle of 30 degrees. And like I said, I'm going to use the equation tool to simply set those equal to each other. My apologies if you can hear whoever's burning rubber outside of my house. All right, so a couple things we have left to define. I'm moving this around. I see that this height is not defined, like we were talking about. So I'm going to go to Smart Dimension. I'm going to click on this line length. we can call that 1.5, like it says. Now, what else isn't defined? If I move this, or if I move this, it looks like this. We need to define this length. Tyler actually forgot to add a dimension for this. So what I'm going to do is I'm just going to call this 0.5. That looks pretty good to me. So now we've got a couple things left to do. If I move this around, I see that this length is not well defined. So, but it looks like on this drawing that the curve of this is lined up with the top of the circle. Now, sometimes you can't make assumptions like this, but because Tyler, when he made this, neglected to actually read it, I'm going to go ahead and line them up like that. So I'm going to click on this one, hold Control, click on the center point, and then hit the vertical constraint like we talked about. And now that's looking pretty close to the actual dimensions of the thing. That's pretty good, except for one more dimension between this point and the line segment down here is 0.750. So that was a little quick, but as you see, as you get better at this, you'll get faster at kind of defining this, especially with these kinds of sketches where you're given all of the dimensions. It's just about how efficient you can be. And as well, we talked about what parameters you actually need to control for certain objects. So for this, it's a little more defined, like there's not many other things you can define it as. But if you ever needed to modify this part, that's just something else to keep in mind. So I'm going to exit the sketch, and it says that it is, right here, it says that it is 2.250 inches thick. So I hit the extrude boss button, 2.250. Look at that, thick. So now we have this guy. The next step we have is from the top. So what I'm going to do is I'm going to hit the front or the top plane and start a new sketch. And now the way I'm going to do this is I'm thinking, all right, so I've got this profile already, and I need to make cuts out of it like this. So what I'm going to do is I'm going to, like we talked about earlier, convert entities. So this is where it gets really cool, the convert entities tool, because as you're seeing right here, this is a curved surface. So how do we make a sketch on a curved surface? The answer is we don't. So what we want to do, unless we're doing surface modeling, which we're not doing surface modeling. So what we want to do is I'm going to click on this, and I'm going to hit, not offset entities, sorry. I'm going to click on this, and I'm going to hit convert entities. And what this does is that from the sketch plane, the view that I'm in, it projects the line segment down. So you see from that curve, we got a rectangle of points projected exactly down. Pretty neat. So if I do that for the rest of this, I'm going to select this part and this part, convert entities, and now I'm going to make all of this, I'm going to make these two center lines construction geometry by selecting them, right-clicking, and then this is how you convert stuff to construction. I'm actually going to delete the extra lines. Let me make this construction too. I don't know if that's converted or not. Oh well. So now we basically, as you can see, have a square outline. And now I'm going to make the rest of the contour to work with it. So what we have here is we have the something that looks vaguely like this. And now, here's another place we could use the pattern tool, or the mirror entities tool. So what I'm going to do is I'm going to come up here and get a center line, hover over this line to get the midpoint, make a midpoint line. And now you can see I can connect this to that, go through, this angle goes from here to here. And so now, now I have all of the lines that I need to mirror this entity. I'm going to define them first, and then mirror them. So the first thing we'll do is just set all these lengths like they say on here, 0.6250, the distance between this and this. On the picture, it's 1.5. The distance between here and here is listed as 1.0625, which this will overdefine our disassembly, but it says 1.06. So that means that's just a checkpoint we have, a validation point. The next thing I'm going to do is go from this line up to here. And since it's listed as the center to center distance, I'm going to put equals 1.25 divided by 2. And actually, for something like this, I don't even have to put the equal sign. The equal sign puts it in your equation window or your equation manager, so you can change it later. But for this, I just literally want 1.25 divided by 2. So I can click that, and it'll automatically do the math on that. I'm going to do the same thing up here. 1.625 divided by 2. I did the wrong dimension. Do you guys see what I did wrong? I did the dimension from here to here. It needs to be from here to here. So I'm going to delete that. I'm going to go from here to here. And now that I actually am going to do it right, 1.625 divided by 2. There we go. That looks better. Last thing, this angle is not defined, but if I recall correctly from the old version of this file, this is supposed to be 45 degrees. So I'll just go ahead and put 45. Looks pretty good to me. Looks pretty right. So now all of our stuff is defined. So I'm going to click on Mirror Entities, and I'm just going to mirror this entire chain. I'm going to mirror it about this center line. So now we have where our cut will be. So if I exit Sketch, I'm going to go now up to do an extruded cut from the Features Manager. And it's going to have me, because I have overlapping contours, I'm going to need to select the contours I want. So I want to cut this part out, and this part, and this part. The direction is wrong though, so I'm going to hit reverse direction. And I want it to cut the entire part, so I'm going to hit through all. So hitting check, that looks pretty good. The final part is just to add this hole in the front, which we can do with the hole wizard, like we said before. So I'm going to click on this surface, hole wizard. It says that this is a 1/2 inch screw, so I'm going to switch to ANSI inch. It is a tap drill, so it is a 1/2. Where is it? 1/2 by 13. So the 1/2 is the size of the screw, and the 13 is the threads per inch, or TPI. And what we're going to say here is the same deal. We're going to go up to next, which means it'll go from this surface to the next surface, which is that. If I position this, hit escape, and it looks like this is in the center of this square. So the way that I'm going to do this is I'm going to hover over this line, get the center point, can hold down Control while I click the second center point. I can make that a horizontal coincident. Do the same thing, hover over this line to get this point, and I just hold down Control to select both of them at the same time. That one's a vertical constraint. The way that I can tell is because every sketch has a coordinate system like this. Remember in the beginning of this session, we talked about how to make a sketch, you need a coordinate system in 2D, and you need a plane. So where you need to be careful is when you're doing some of these dimensions, if you're in a different coordinate system than your 3D part, you need to be aware of that. So for this one, our Y and our X are in the same direction, they're collinear, but the X is actually negative X. This doesn't make a difference for stuff like this. But if I would have started the sketch like this, if I was in this orientation, then the Y might have been this way and the X would have been this way. So if I would have looked like this, then a horizontal constraint, or actually, So let's say that I'm doing it like this. If I'm looking at it from this perspective, you can see that my vertical direction is actually this way, but my horizontal direction is actually this way for my plane. But for my part, my horizontal direction is, it also moved. Basically, I'm having trouble coming up with an example for this, but make sure that your coordinate system align, because if you do the wrong dimension, then you'll have a bad time. It'll say, uh-oh, you can't solve that because that's not right. And you get the red. So now that I've done that, I hit check. And the part is all done. It says on the picture that it is made of brass, so I can just hit edit material in the feature properties manager. It's in alloys, I believe, or other metals maybe. Okay. But we can turn it into air. Oh wait, brass is a copper alloy, isn't it? Yeah, there it is. I should know this. I've taken 2 materials classes, but that's okay. And so now, take a look at the picture. Look at that. That went pretty well. I think we've got time for maybe one more example, but we have gotten through 3 so far, so I think maybe now would be a good time to open the floor to some questions, or other comments. I think that we can leave exercise 4 and exercise 5 to do on your own. The link to the actual slides should be in the description. Angelo, I believe it was SolidWorks slides 1-2, right?
Oh yeah, it was. I'll link that after this. This actual live stream should go up right afterwards, but I'm gonna cut the little intro out where we were sort of figuring out what was going on. But I would say
that'd be a good idea. Thank you.
I would say by tomorrow the link to the slide should be in there if you want to take a look at them.
Cool. For those of you on ROV, they should be in like our main channel as well for Slack, and you should be, if you're not shared already, we want to get you shared on the what is it? It's the Google Drive is important to have you on. There we go. I'm going to try to put this back just a little bit so that it doesn't get too angry. All right, so I'm gonna unmute my Discord if you guys want to mute the stream, and then we can answer any questions directly now. And I'll just let it sit for like 30 seconds to hopefully let that lag go away. Can you guys hear me in the Discord now? I guess I can just tell you, mute the stream.
Are you going to repeat the questions, or should I mute your audio?
The stream is not done. We have about 10 minutes left, and instead of doing one more part, I think it'd be a good time to answer any questions you guys might have or any comments. I know that some of you might have some previous CAD experience, so we'll talk after this with you guys individually to see if like you got stuff out of this or if you didn't. So we can talk about if we want you to still come to the second and the third session, depending on how much experience you actually do have, or what what additional help or knowledge you need before you join the team or get started on your projects. But are there any closing questions going forward? And I'll just repeat it for the stream. All right, well, if there are no questions, then I think I'm fine ending just a little bit early. I don't really want to rush through another part just to say we got through it. So I would say if you guys want some interactive experience with this, you can go take a look at that 4th part and the 5th part on the slides. Like we said, those will be available. I see there's maybe chats in. Oh, Angelo sent something a minute ago in the general chat. we said, this stream will be available for review if you want to like see the answers, quote unquote, for how to do these. If you want to work on number 4 and number 5, then talk to us, like Angel or myself or Logan, at any other point in time. Just let us know. Other than that, thank you guys for coming, and I hope that you got something out of this despite the limited nature of this format. So I hope this worked out. Thank you so much for coming. So yeah, Angelo, I guess if you want to cut off the stream.